Hey guys, this is the third and final video for the week. This is 14.1 through 14.2, and we're going to start talking about the tangent graph. Now, you have to understand the tangent graph has some specific issues that come up within the period of its rotation because it's the stacking or the solving of y divided by x. Let me actually go back a couple of weeks. Let's see, right back about here. If we go back and look at the unit circle, okay, the tangent is defined as the y divided by the x. Well, the y being 0 divided by 1, the x, is 0. And that makes fine sense. It's not an issue. However, when we hit this 90-degree mark or this 270-degree mark, we end up with the y value 1 or -1 divided by the x value 0. And so what that means is that we're going to get an undefined value. Now, when we've done this before, whenever we divide it by 0 in a graph, we put in a vertical asymptote. That's going to continue with the tangent graph. So we're going to end up with, in 4 marks, right? 1, 2, 3, 4, we would see 2 different asymptotes. That's what we normally would expect and think. However, something very interesting also happens. It has to do with how do we actually evaluate the tangent. And so if we think about the value of the tangent here, root 2 over 2 over root 2 over 2, that's 1. Over here, it would be -1. Down here, because they're both negative, it would come back to 1. And all of this stuff down here would basically be a carbon copy of what happened on the top half. What ends up happening as we look at the values, we start to see that the tangent actually repeats itself more frequently than the sine or cosine. The sine and cosine had to make it all the way around the circle to get back to its starting point and have covered all of the different options. Remember, the sine had to go up to its high point, down, all the way down to its low point, and then back up to the middle. And cosine started at its high point, went all the way to the bottom, and all the way back up to its high point. To complete the cycle, it had to go a lot further. With the tangent today, we're only going to have to rotate half the distance. What that means for us is that when we go to do the period, the 4th mark, it's going to happen, in half the time. So that's going to impact the way that we create these graphs. So let's jump in and look at some graphs of tangents and figure out what's different about them and how do we manage that. So first thing we're going to do is start with our basic equation, which will be y equals, okay, I'm going to put an a here just because it's traditionally there, and then bx plus k. A couple things I'm going to tell you right now. The a, there is no amplitude. Okay, these tangents, when you see the graph, you're going to say, oh yeah, it doesn't have a high point and a low point. It goes up and down forever because of those asymptotes. When it comes to finding the period, like I said, it happens in half the time. So the period, the 4th mark, is going to be pi over b. Not 2 pi over b, half that, just pi over b. And k is still a vertical shift, but we're not going to do any vertical shifting for the tangent this year. That's something you'll cover again in pre-calculus. It's not a big deal. It's very similar to sine and cosine. Almost feel like I should have done it, but I wanted to make sure you got lots of sine and cosine graphs done. So I kind of just skipped over that. If you know how to shift any of them, then you can shift the tangent as well. So this number, this amplitude, it's not an amplitude in the tangent. It does have a specific value, and we'll talk about what that value is, okay, as we produce these graphs. But I'm going to start with the most basic one. Y equals the tangent of x, okay? In this graph, okay, first thing we have to understand is we go back to that unit circle idea, right? The tangent over here, because it's y over x, this is the point 1, 0, the tangent would be 0. Up here, the tangent is undefined. Here it's 0, and here it's undefined. but we're going to complete the cycle in just half the rotation. Okay, so I'm still going to go out 4 marks. 1, 2, 3, 4. 1, 2, 3, 4. I'm going to put a dot right in the middle because tangent will start at 0. Now here's kind of the kicker. We are going to figure out what our period is before we start graphing this for a specific reason. Now, there's no number next to x, so we can assume it's a 1. So then the period would be pi over 1, or just pi. I am going to come in and label that. And then I'm going to label the halfway mark. Okay. Same thing over here, negative pi over 2. If you just split it in half. Half of a whole is a half, so, and then you get negative pi. Okay, if you remember, the sine and cosine always end their period where they started their cycle. And so if I'm going to start here at 0 and over here at pi, I'm going to have the same dot there, and I'm going to have the same dot there. Okay. The next thing is recognizing that halfway through its phase or through its period, there's an undefined value, means that at these second marks that we created, we're going to put in a vertical asymptote. Okay. All we really have left is to draw our tangent. Once you've seen a tangent, you know what they look like and you move on with your life. So I'm just going to kind of create this first tangent for you. It's going to be a zigzag that comes through and crosses through a bit like this. Okay, you can see it's just kind of following those two boundary lines. Now, the value of the number in front, what we would have called the amplitude, is not the amplitude. But if I go to 1 and negative 1, that is where my tangent should be when it gets to the first mark. So I should be getting a dot about there and there. That's the actual meaning behind that number. If your second mark is your asymptote, your first mark should be at that value. But obviously this goes up and down forever, so it doesn't have an amplitude. All right, so what happens out here beyond these asymptotes? Well, the graph repeats itself. Okay, now when I was in high school, I was just taught, hey, finish the cycle a little bit to the right and a little bit to the left. So if you think about it, from here, it's at that dot right there. Okay, these dots are the same. What does it do? Is it goes to the right? As it goes to the right, it curls up like this. And this dot, again, is this dot right here. What's it doing on the left side? It's headed downward on the left side. So there's our tangent graph. Personally, I actually like to extend this just a little bit. If you go out 2 more marks, you could draw in another vertical asymptote. And same thing this way, 2 more marks, another vertical asymptote. And then you could just finish the graph out by making the identical curve that we made in the first one. That's it. Like, I prefer this because I can see the cyclical nature, the repeating. I know where the next asymptote is going to be. It's 4 more marks and so on. I'm just going to look at one more of these. By the way, if it was negative, this would just be flipped upside down. Instead of going up to the right, that's positive. A negative tangent would just trend that way. But the asymptotes would be the same, all of that same information. So let's look at an example. Let's say we have y equals 1/2 of tangent of 2x. We'll just do that one. All right, so the first thing, I'm going to create my graph. 1/2 means that this will be 1/2 here, and this would be negative 1/2. It doesn't really matter that much other than that first point. I go 1, 2, 3, 4. 1, 2, 3, 4. Now I know that the second mark is going to be my asymptote. So I'm going to go ahead and put those asymptotes in. I also know that my tangent crosses at 0, 0. and it's going to cross at this fourth mark to the right and fourth mark to the left, but I do need to label those marks. I know that because this is a positive, it's trended upward, and if I want to put the dots where they belong, it'd be -1/2 would be right below that, and right there. So I mean, here's my graph. Turns pretty aggressively when it turns. I'm going to go out, create my 2 next marks to kind of create that repetition. Again, these graphs, they all have the same behavior. They all can look the same. The issue is, can you get the labels in correctly so that you actually have an equation that matches the graph that you produce? Because that does start to matter when you have the differences in these equations. So I took care of that guy, that 1/2, it's fine. The period is supposed to be pi over b. And since the number multiplied by x is 2, that would be pi over 2. So if I'm going to put pi over 2 at the fourth mark and -pi over 2 at my fourth to the left, what would this middle mark be called? Well, 1/2 of a 1/2 is a fourth. So this would be pi over 4 and -pi over 4. And that's it, guys. That's all it takes to graph a tangent. They're all very, very similar, and you only have about 4 or 5 of them to do. So good luck, and see you during live chats.